N. What is that? Sir, this constant is supposed to be nRT. Yes, the value of constant is nRT. So whenever we are drawing the graph, we say something like this. Suppose if I draw the graph, then I have taken here PV and I have taken here in this case either pressure or volume. If you are able to recall your graphs, right, don't turn the pages, just turn the mind. You can understand, if you recall, if you force your mind, you can recall it. What we have written something like this. There is something straight line I have written like this, and there we said, sir, this is supposed to be the value of constant. That much we have said, right? Or suppose for example you are discussing the same thing. One more way of understanding is, suppose for example you say, no sir, I have taken the graph like this. Pressure is equal to some constant, I don't write now, okay, I am knowing that this value into dash 1 by b. This is also one of the way of equation. If you are taking this graph, what we have said, sir, we are talking about y is equal to mx. So you have taken the graph like this. Here you said, sir, we are having pressure. And here you, if you take 1 by v, I have taken two graphs there, 1 by v as well as v also. If you have this type of situation, what is the straight line passing through the origin? Nice. Now the question is, sir, what is the slope of this graph? On that day, what I said, constant, some constant I said. No, now we have the value of constant. This slope of the graph is equal to nRT. Able to understand that? Now, suppose for example, here you have a question. Here you have a question. What is that question? Let n is equal to 1. What is the meaning of that? I have taken 1 mole of gas. Nice. Then what is temperature? Ct is equal to, say for example, 0 degrees centigrade. That means I am trying to enjoy STP condition, 273.15 kelvins. R value we know it. If you have this type of situation, suppose it is given, then the question is, sir, what is going to be the value of slope? Remember, here in this case, the value of slope is equal to, what is that? nRT. nRT. 1 into, what is R? 0.0821 into T. What is T? 273. For calculations, it's okay. 273.15. Now, if you are having this one, then 0.0821 into 273.15. If you multiply that, you get 22.42. Okay, a beautiful word, a number we are getting. What is that? 22.4. And we know 22.4 is volume of 1 mole of ZSTP. Yes, remember that. If suppose for example you have taken pressure by 1 by V, slope of this graph is always 22.4 provided number of mole is equal to 1. Now question is asked like this: in case of P versus 1 by V graph, slope is found to be 44.8 liters. Find number of moles. If it is 22.4 liters, number of mole is 1, because we are not going to change this, and we are talking about this to be as STP condition. So this value that fellow can change, and they can ask you number of moles, or they can say if number of mole is equal to 1, what will be the numerical value of the slope of the graph, right? Now, how to proceed for this, sir? What about the value? This is supposed to be volume of 1 mole of gas at STP. We have taken standard temperature. If suppose for example you are discussing about pressure volume relation, this is one of the graph. Similarly, when we are having that graph, what is that? Just now I have said, suppose for example you are saying the PV product and this RT value, then that is supposed to be some constant value. Always the constant value will be nRT. This is one way of understanding ideal gas equation for Boyle's law. I am not changing the heading. I am keeping as it is, saying PV is equal to nRT. Now suppose for example if I say V is equal to nR by P into temperature. Now look at this. Is it not V is equal to KT? Acha, V is equal to KT means, okay sir, we are discussing about Charles law. Fine. So ideal gas equation, if you write like this, Then the question comes, how do you proceed for this? No, sir, it is very simple. Y is equal to dash mx. Okay, now we are having two types of graphical representations here. One representation is, suppose for example, if you say, sir, this is something like this. If I take volume along y-axis and temperature, which temperature? Kelvin temperature, remember that. If I take this one, then again it is y is equal to mx, straight line passing through the origin. So you may have this type of graph, right? And for that graph, what about slope of the graph? Very simple, sir. Slope of the graph is equal to nr by p. Depending upon the value of that nr and p, we can have some slope value, right? Pressure is given in atmosphere, number of moles 1, r is 0.08 to 1. So slope is equal to at 1 atmosphere for 1 mole of gas. Whenever I say gas, it means ideal gas. We never refer a number of times the name again and again. Slope is equal to, slope of this graph is equal to, what is that slope? N into R. N is 1, P is 1, R. What is the slope? 0.0821. Be careful, be careful. These type of questions are theoretically and conceptually possible. Orally, without having application, you have to, all these things must be in your mind. Suppose, for example, you are saying, no, sir, I have taken
वैसे आपका
different
ना
type of
ऑलरेडी जो
approach.
जूते हैं ना तीसरा
Suppose, for
जूता मेरे को आ
example,
रहा है
if
क्या?
I am studying the same graph,
वैसे दो मेरे हैं वो तुमको दे दिया लेकिन तुम ना लेना ले लो चलो
this
क्या
manner,
देखने तुम भी
I have taken here volume, of course in liters, and I have taken here in this case temperature, but remember this temperature is in degree centigrade. If it is in Kelvin, what happens? You learned this graph already in the previous case. You said, sir, the graph will be somewhere here. When you are talking about this, it will go from here to this point. Now, what was the equation here? This equation is V is equal to KT, right? That K is as it is the same. What is that? NR by P into KT. What is KT? Degree centigrade plus 273.15. Right. Now, when we are talking about this one, if I take this equation, what is that? V is equal to, if I'm writing this equation, V is equal to NR P plus NR by P into dash. Now this T degree centigrade may be some temperature, say for example 80 degrees centigrade, so T. So when we are discussing this here in this case, V is equal to mx. Is it not mx? Yes, mx plus nr by P into 273.5. For that purpose, suppose for example, if you take this part, what is this part called? Intercept. This part is known as y is equal to mx. Is it slope of the graph? Yes, sir. Y is equal to mx plus c. If you are discussing this, then how do you proceed? So this c is equal to nr by p into 273.15. Now that fellow will create a question. If n is equal to 1, pressure is equal to 1, and temperature is equal to 0 degree centigrade. If suppose you are saying 0 degree centigrade, what I have written here, whatever the value given to you, plus dash 273. If it is 0 degree centigrade, this will be vanished and we get left out with 273.15. So if I am taking this value 273.15, then we are left out with n by p 11 r into this one. Now listen to this carefully. Where you have done it, r into temperature, r in temperature, r value is 0.0821. Again, this value is how much? Yes, but it is applicable for 1 mole of gas. Suppose for example, if I am having 2 moles of gas, this point will, as it is same, the graph will go like this, 44.8 liters, right? Furthermore. So they may ask you these type of beautiful questions with respect to IIT mains. So ideal gas equation can be applied in case of Boyle's law and Charles' law to understand the value of constant. In previous class, I said some constant k. What is k value if you want to understand? Now, this is the way to proceed for that. Next. Similarly, you can do this job. That is your homework. Gay-Lussac's law. Take down that one and try to apply what happens here in this case. What will be the value of pressure? The graph will be P versus T. Come on. Suppose, for example, if I am saying some other discussion as what is that? Sir, I am having pressure is equal to, wait a minute, boys. Now, pressure is equal to, suppose for example, I want to go application of ideal gas equation in different manner, right? How to proceed with the different ways. For that, we say PV is equal to nRT. Basic statement. PV is equal to nRT. Right. This is for n moles of gas. Right. What is the meaning of n moles of gas? One gas, n moles. Suppose, for example, you're saying, no, I am not doing like this, sir. I am discussing for mixture of gases. Okay, I'll write one more thing here. For dash. No, sir. PV is equal to RT. What is that? For 1 mole of gas. No, sir. If suppose, for example, I am having 1 mole or n mole or 10 mole, no problem, but I am not having a gas. What is the meaning of this? For 1 mole of a gas. What is the meaning of this? For 1 mole of a gas. For a mixture of gases. What to do? No problem, sir. Very simple. Very simple. P V is equal to RT. Let me enjoy like this. What is this P? This P is called total pressure. This P is known as total pressure. Right? Sir, what is this P? Pressure of gas. A gas. When there is a gas, there is no meaning of word total. Right? Similarly, a gas here, n moles of a gas. But here we are having, therefore, some people say, some authors write down here only PT. Achha. What is this V? Sir, let us write V total. No meaning of writing V total because volume of gas is equal to volume of container. Whether you are having 1 gas or 10 gas or 20 gas or 40 gas, it is volume of container only. Okay. Now, if suppose for example you are having mixture of gases, then don't write N. What you have to write? Sigma N. Right? Gas 1, number of moles of gas 1 plus number of moles of gas 2 plus number of moles of gas 3 and so on. R, same thing as it is universal gas constant. Temperature also unique value. You cannot have one container with 2 different temperatures in case of mixture of gases. Here you have learned a very beautiful point in case of advanced examination. When you are having multiple answers, mixing of gases is isothermal process. Are able to enjoy this beautiful, today it is said to be what we can say gift for you. Mixing of gases will never change the temperature if it is mixing of gas. Sir, why you are repeating the word mixing of gas? Yes, mixing of gas does not mean to say chemical reaction. Okay? There is always a beauty to enjoy the science. Mixing of gas is different, chemical reaction of gas is different. When you have chemical reaction of gases, there will be increase in temperature, there may be decrease in temperature, possible. I don't know, because I have to know the reaction first of all. Who is that fellow, gas 1, gas 2? When I am saying mixing of gases, it is a mixture, there is no chemical response. Wherever there is no chemical reaction, wherever we have mixing of gases, of different gases, remember it is always an isothermal process. A beautiful question to enjoy. Come on, sigma n. Okay, what is the meaning of sigma n? N1 plus N2 plus N3. Nice. When you are saying this type of situation, you are saying Pt is equal to sigma n. No, 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 sir. I want to enjoy the case. Suppose, for example, if I am saying Pv is equal to nRT, again one gas, then Pv is equal to, can I write like this? Why not, sir? If I am writing like this, can I write Pm? You people are genius people. DRT. Is it correct? D. Weight by volume. Mass by volume is density. Yes. This is another way of writing ideal gas equation for a gas. For a gas, we have Pm is equal to DRT. Pressure of the gas, right? Pressure of a gas, I'm saying. Molecular mass of that gas. Not molecular mass. This is density of the gas. R&T, your old friends. For a gas. Okay. No, sir. Suppose, for example, if I'm having mixture of gases, very simple, sir. P total. Right, today you are listening a new word in your life. No, no. I think in my stoichiometry I have used this language. What is M? This is known as molecular mass of mixture of gas. Mixture of gas. No, sir. In stoichiometry, we have written it as mean molar mass. Yes, when we were discussing about solution topic. If you are not there, no problem. We'll discuss again this one. This is known as molecular mass of mixture. Some authors say average molecular mass. Some people say mean molar mass. Where is M gone here? Yes, sir. Something is wrong. What is this? Mean molar mass. M, mean molar mass. Right? Is equal to, when I say D, density of a gas. When I say M, molecular mass of a gas. No, 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 no. Molecular mass of mixture. ठीक है. Density of mixture. Yes. This is not known as mean density, but it is usually called density of mixture, and this is known as mean molar mass. And this is R, this is T. This equation is used whenever you are having mixture of gases. Now question comes, sir, what is the meaning of mean molar mass? Right? We have done it in the the stoichiometry, but again we'll do it. First write down this, then we'll proceed. Go ahead. This is a very simple topic and very useful to score the marks. Try to finish day by day, daily 1 hour at home. If you go on studying notes only, enough, notes only. And once we finish one topic, go for questions. Questions, first classroom question, then our theme.
Huh? How? Okay, ra. Yeah. ಯಾಕಂದ್ರೆ ನಾನೇ ನೋಡ್ತಾನ
Fine. Shall I proceed? Is it over, everybody? Go ahead, right now. Shall I proceed? Come on. Once you are saying it is a mixture of gases, then P total volume of container is equal to, okay, you people are genius. Why to repeat again and again? PM. This is mean molar mass is equal to DRT. What is D? Mixture temperature along with R. What is the meaning of mean molar mass? Remember, whenever we are mixing the gases, right? Mass, molecular mass is basically in your mind, what you are having mindset. Sir, molecular mass of a gas, sulfur dioxide 64, oxygen 32, sulfur trioxide 80. Every gas should have one single molecular mass. How can you talk about molecular mass of mixture of gases? Yes, remember, whenever we have a no chemical response, usually we can say, sir, mixture, then it is possible to find out the molecular mass of mixture, because whenever we are talking about mixture, remember that weight is supposed to be added. For example, if I say like this, weight of mixture, is it possible to say weight of gas 1 plus weight of gas 2 and so on? Yes, sir. This is law of conservation of mass. When you are saying like this, we know a statement, right? Number of moles is equal to weight by molecular weight. We have done it. Okay, weight is n into m. Therefore, n into m. What is this n? This is called number of moles of mixture, right? And this is known as mean molar mass. I can apply this for both chemical reaction, no chemical reaction, both it is possible, right? Depending on the question. What is W1? W1 is nothing but N1 M1. What is W2? N2 M2. Number of moles of second gas, its molecular mass. For example, PCl5 gives you PCl3 plus Cl2. What is this? M1. What is this? M2. What is this? M3, right? Now, when you are taking this one, then mean molar mass
Rồi, rồi, rồi.
is equal to, shall I take this here? Yes, sir, why not? N1 by, is it possible to write down like this? Yes. N2 by, is it possible to go like
À,
this?
đôi lipstick không rồi? Cái lipstick
I
ấy.
think you people are genius, therefore you can understand what is this
Thì
term.
có ai
What
có
is
ai thì
this
bड़ा.
term? Sir, mole fraction. Yes. This is known as mole fraction of gas 1, molecular mass 1 plus mole fraction of gas 2,
Andar on zero.
molecular mass 2. This is known as expression for mean molar mass. No, sir, we are NPC students. We can enjoy something like this: summation of xi mi, where x is mole fraction and m is
Như lại.
molecular mass of individual gas, and this is mean molar mass. What is the possibility? I is equal to 1, I is equal to any number, right? This is the way with which we can calculate the mean molar mass of substances. If suppose mean molar mass is given, we can also find out pressure of gas, density of gas, something like this. There are so many types of problems possible here. Again, I am saying I am discussing problems, numerical problems in theoretical way, a very systematic and beautiful way for teaching and also for learning. Come on. What is that case? C over D. When we are discussing this, we people say, sir, PV is equal to nRT. When I was discussing about gas laws, I was using a statement. There are four variables: pressure, volume, number of moles, and temperature. We should not talk about to study relation between all four simultaneously. We keep two constant and remaining two are discussed whenever we are proposing a law. Whenever we are proposing a law, this is the method. Two are kept constant, remaining two are studied. But whenever we are in the lab, then all we can do, because I know ideal gas equation. Therefore, I can say like this: P1 this is also one of the way to solve the problems if all are variable. Suppose, for example, that fellow says pressure is changed, volume is changed, number of moles are changed, temperature is changed. If initial values, this one find the final value. That is the possible way of creating question. Next. Suppose, for example, you are having ideal gas equation and you want to apply the ideal gas equation somewhere like this. Consider Suppose, for example, you are having something, a lake or a river, or sometimes it's a sea also. Suppose, for example, this is the depth available. I'll say H. And here we are having a beautiful fish right down. And there will be something okay, nice. Suppose, for example, this fish releases a air bubble, right? Air bubble. There will be certain number of moles of gas, right? And this air bubble at this particular point under the depth experiences total pressure because of number one. What is that? Because of atmosphere. There will be some pressure exerted on this, and because of this liquid column, wherever we have liquid column, there will be some pressure. Therefore, this bubble experiences, okay, let us enjoy another color, experiences certain amount of pressure. But here in this case, the system is under pressure. Always the
अच्छा
gas
आप
wants
पहले
to
तक
come to
प्रैक्टिस
a
करते हो ना
system where pressure is less.
मैं दिखाता हूँ
Pressure is supposed to be less. So it will slightly go up. As it is going up, pressure will be decreasing. So those air bubbles which are under the ground, in the sea ground, sea surface depth, they always try to come up because they want to have lower amount of strain on them, right? For that purpose, they should rise up. You are also under strain every day, right? Physics people, chemistry people, maths people, all they are having, this is to be done, this is to be done. Yes, I have to overcome this strain. What to do? Very simple, sir. As the balloon is trying to come up to overcome the strain, I should do daily 1 hour study so as to come up out of the strain. Otherwise, if it is a storage type of study, it will be always under strain. As it is going up now, what happens? Nothing happens, sir. Pressure decreases because length of liquid column is decreasing. If pressure is decreasing, volume increases. What is constant here? Number of moles are constant. There is no change in number of moles of this. And what is constant? Temperature is assumed to be constant. That fellow can create a question with the variation of temperature also, with same temperature also. I am assuming a smaller, a simple case, right? If T is constant. With respect to T, I should say if word. But with respect to number of moles remains constant. I should not say if in case of number of moles. Then what happens? Nothing will happen, sir. PV is equal to constant. When you say PV is equal to constant, P1 V1 is equal to P2 V2. Okay, very good. What is the meaning of P1 V1? P1 at the top. What is the meaning of P2 V2? Bottom. Yes, these type of problems can be solved if that fellow will ask you what is the final volume, what is the final radius. Simple question. No, no, no. How much is percentage rise in volume? What is the percentage change in radius? These type of questions are beautifully possible in case of means. Okay, how to solve the question? Very simple, sir. Pressure is equal to dash 1 atmosphere. Which pressure? Outside pressure. The top we are having this pressure into its volume. What is volume? Sir, volume at the top is equal to, right, pressure at the bottom. Okay, that is our job to understand. 1 plus, this is what is pressure at
अभी
the
मुझे ना
bottom.
घर
1 is pressure due to
पावर बैंक को
atmosphere,
लेके
plus another is pressure due to liquid column. Come on. Can you support me? Anybody? Pressure, atmosphere, 1. Pressure due to liquid column. Can you support me? Anybody in the whole class of okay, 57. 63 were there. It becomes 57. 58. Can anybody tell me what I should write here? Depth of the liquid is H. 10.33. Sohail, आपका आंसर बिल्कुल सही है, right? 1 plus h by excellent, excellent, very good. But not 103.4. Abdullah Khani, it is not like that beta. It is h by 10.33 if I am discussing in meters, or else we have to add. You are saying in centimeters. Very good, excellent. He is saying in centimeter. Okay, go ahead with centimeter. I will enjoy this. Right? Sohail Ahmed, 10.33 you are saying. That is also correct. That means you are discussing in terms of meters. Very good, excellent. Because here, remember that most of you, those who have not given answer, they may be thinking that, sir, h by 76 centimeter. Are you able to understand? अब जरा अपने अपने जहन में झोंकला, हाँ हाँ मैं यही सोच रहा था सर, right? Most of the students will say, sir, answer instantly. This h by 76. Yes, h by 76 is correct. If fish is having a habit of swimming in mercury, bad luck. Swimming is possible only in case of water. Therefore, 1 plus h by 10.33 meters or 1033. Don't write 1034. Abdullah Khani, 1033. Okay, 0.34. That is the correct number. Don't change that. Into volume in bottom. This is one way of asking question. Sometimes that fellow asks in terms of radius. No problem, sir. We are MPC students. 4 by 3 pi r cube, which are bigger. At the top, you are having larger value, is equal to 1 plus h by 1033. H is in centimeter. Okay, into what is that? 4 by 3 pi small r cube. From this, that fellow can ask you anything, percentage, rise, all those things. Okay, that will stop here. Let us write complete this and we'll proceed. Go ahead.
Dida, Dida, please tell मेरे को कॉल करके बोलो Dida, प्लीज तनु को कॉल करके बोलो इंटरनेट बंद करके बोलो ना मेरा फोन क्लास से प्लीज
अब क्या है उसे अच्छे से अच्छा लोग क्या करना और कल दूसरे में बात क्या करा कर दीजिए वहाँ पे तो काम होता है मुश्किल साइंस शुरू कर रहा हूँ ये
अरे क्या चीज़?
तो ये जनवरी से शुरू कर सकते हैं तो 2-3 महीने में सोशल स्टडी को तो खाली 8 महीने का रहता इंग्लिश हो हिंदी वो आएंगे देखो सारे ये व्हाट्सएप लेवल आते 9:30 आते हैं 11 साढ़े 11 तक नहीं पूरे बच्चे वहाँ नहीं किसी से बैठे ना आपके वाले पे कोई रहता खरीद नहीं है बच्चे ज़्यादा उधेड़ में पढ़ाया हाँ बेटे वो नमाज पढ़ा के आते हैं नहीं वो चले वो व्यवहार जाते 10 बजे साढ़े 11 बजे रिप्लाई तो पूरा बात करती है ना मगर मेरा उसको एडिशन प्रोडक्ट नहीं है मैंने बताया था ना एडिशन प्रोडक्ट नहीं है
फीस कम करते रहते हैं राजरी मस्ती को 2 GB RAM का बहुत ज्यादा नहीं 3 GB RAM का Redmi 9 है बोल के फ्लिप फोन है जी तुम्हारे से फोन से 1/2 इंच बढ़ के रहता हाइट हाँ सेम है पूरा मॉडल लेकिन पीछे लोग 4 कैमरे रहते ना डेली के पुराने फोन को 6 Pro कैसा था 2 कैमरे वैसा था पीछे भाई कुछ भी फर्क नहीं है 3 GB RAM 32 GB स्टोरेज 4200 में आता उनका फोन एक्सचेंज करे बस
Is it over? Fine. Remaining, we have some more ways to enjoy numerical problems of ideal gas equation that we'll discuss in the next class. Thank you. Assalamu alaikum.